All right, so the way we're going to start is, and again, we're asked to use the fundamental theorem of calculus, right? So we're going to start just by kind of putting the basic structure in place. So we know it's going to be an integral, it's going to be an area function. That's what we mean when we say we're going to use the fundamental theorem. We don't know what the lower bound is for sure, although if you do enough of these, you'll be able to figure it out pretty quickly. The upper bound is going to be x. We're going to take this function here and we're going to put it in as the integrand. But we're going to have to use t squared. We can't have the same variable in both places, here and here, because this is actually the independent variable in our area function. And then it's going to be plus c, okay, because when we take the derivative, what we want is to end up back at sine x squared. You can see if we, based on the warm-up we just went through, that same principle, right? When I take the derivative of this, I'll put the x in here, and I'll have sine of x squared, and then when I derive the c, I'll get 0, obviously, so I'll get back to sine x squared. The question is, what is the c? Because, so, if we didn't have this, right, whoops, if we didn't have that, right, then we would be nearly done. But we have this. We know that the point x equals 1, y equals 5 is on the graph of y. So we can use that to figure out what c is and the lower bound. Think of it this way. If I know that when x equals 1, y is 5, what I'm going to do is I'm going to pick the lower bound to be 1. I can pick it to be anything, because when I derive it, as we saw in the warm-up, remember in the warm-up, it didn't matter here what the lower bound was. We could put in whatever number we wanted here. We were going to end up deriving, we're going to end up taking the derivative of a constant, right? So we can pick whatever is convenient for us for the lower bound. And it's really convenient to pick 1, because if I pick 1, then I can figure out what c is. Because if I pick 1 as the lower bound and I plug in 1, I will get the integral from 1 to 1, which makes this entire thing 0 right here. So this all becomes 0, plus c. Well, what does c have to be? Well, it has to be 5. We can even show that explicitly, right? We could plug in 5 here, we could plug in 1 here, and then solve for c. What you'll get is 5 equals 0 plus c. In other words, 5 has to be c. So we get our final answer as the integral from 1 to x sine t squared dt plus 5. And again, you can always check your work, right? So you can always plug in 1, you'll get 0 for the integral, plus 5, so you will get the point 1 comma 5 is on the graph. And it looks sort of weird because this is a weird way to write a function, but as we saw, Desmos can graph something like this. So yeah, so it's that's really all you have to do. What questions do you have on that?